Hello, everybody. And today's Summer Bridge, we're going to be talking a bit about unit testing, what it is, where you use it, and how to implement your first unit test. To get started, I'm going to show you right now. This is the tutorial unit test that we'll actually be recreating today from this tutorial on Microsoft, the walkthrough, create, and run unit test for managed code. I'm going to post a link later on so you'll be able to follow along, but you'll see by example what we're doing here. This is the test tutorial after it's been completed. You'll see what happens is after we've built our unit test, we click this run all test, and you'll see on the side here, this is our test explorer. We have this little green icon up here. And what's happening is that we have 3 tests that we have written in our project that test for code inside of this bank account class that will be provided to us through the Microsoft tutorial. And what it's doing is it's running some tests on the code, making sure that when something happens to an instance of a class, that it actually returns the result we wanted. And if something happens and we don't get the result we expect, we'll actually get a different color icon. So here they're all green. I'm just going to change this value to something else right now. I'm going to change it to 60, something small. And now when I run my test again, we'll actually see it's turned red. And that's because on this method that we were using to test, our result here is no longer correct. This should have resolved to 744. Instead, it resolved to 760 and it threw up an error. And this is the beauty of testing these unit tests, because what a unit test does is it tests for the smallest possible component as a part of a class. And so this is testing if we were to debit an amount. So if we set our balance here to 11.99 and we pass it in, and then we try to debit 455, it should come to 744. And that's what this code is doing. But if it comes to 760, if we've changed our code someplace and is no longer returning the result we wanted, it will right away let us know that something's up. And this is actually kind of the basis for the paradigm of test-driven development. It is our way of allowing us to test our code as we go and catching errors that happen quickly instead of having to go back and tear through all your code and finding out where things happen. Because code itself is not static. Once you build a class, it's not necessarily going to stay the same. It will be evolving. You will be refactoring it. So this allows you to always catch those issues early on. I just brought up test-driven development. That is a kind of a development paradigm in which people will actually write out all the tests for your code before you even write a line of code. And so what that means here is, in the example they've given us this bank account class. And if anyone's here has built a bank account class, you'll know that it tends to take a balance, and you tend to have methods that interact with that balance. They will either debit or credit that balance. And you'll see that here. We have a debit method and we have a credit method. Well, we know that if we had a debit method, that it should take the balance and it should subtract a certain amount. So it's basic subtraction. We know that. Same thing with credit. It should add a certain amount. So with this in mind, I would actually come over here and I would have created this method, this test method that would automatically be asking for this kind of information. I would literally have written all this out first before even writing a class. So that way, as the programmer is building out the class and everything, their names should be similar. Their names should be the same. So that way everything kind of hooks up properly, but they know right away if their code's working. This might sound like a lot of extra work because you're basically writing all this code for something before you've even started to build the project. That's where conversations online kind of differ on whether or not test-driven development, excuse me, is really that good. There are, much like everything on the internet, lots of discussions, some angry, some not. But if you figure how much time it takes to solve these problems over how much time it takes to write tests, you can see an argument for people doing test-driven development. It's actually, once you get used to writing tests, it's not that difficult to implement. And we'll even take a look at augmenting kind of our own tests here. So we'll go ahead and get started. I'm going to create a new project. Again, I'm going to follow this tutorial right here. create a project to test. I'm using Visual Studio Preview 2022. This does not matter. Really, any form of Visual Studio will work for you. I'm going to create a new project. It's going to be a C# console app. So create new project, C#, and we'll do our console app. Because here, this is all about the test. We're not so much worried about creating GUIs or anything, but know that every language has some form of unit testing. This is how important it is. So we're going to hit next and create a console app. I'm going to say bank. They actually ask us to name it bank, but later on they'll give us a different name. So I am going to go ahead here and grab, let's see now. I'll just call it bank 2. Bank 2. Now, keep in mind, if you are working with .NET 6, you may notice sometimes when you run your code, you don't have a main up here. This is because they're using a new kind of template system that gets rid of main. I prefer to know where main is so I can control where my code is. So I'm going to use this do not use top level statements. I'm just going to click this button here and hit create, and it will give us our main like we've been working with before. Here we go. So we have our program. And just as a reminder, everyone, I always put comments on the closing curly braces so I don't worry about losing them. Because as anyone who's spent many hours during midterms losing curly braces, this will save your life. You are welcome. So we're going to come back down here. We've named our project. We're replacing the contents of program.cs with this right here, this bank account. I'm actually going to take bank account. I'm going to come all the way down to the bottom, and I'm going to make sure to grab this main also. We're replacing it inside of our class here. And then paste. Let's see if it yells at us. Not yelling at us, that's good. I'll tell you also what's happening here because we are building a class inside of another class. If you haven't experienced that before, let's make sure everything works. I'm going to run. Perfect. So all of our code is working. We have our class in here. And now as we come down, we are going to rename this really quickly. I'm going to grab this and just rename. We are good to go. So I've already run this, but here you'll also notice that it says build solution. For anyone who doesn't know, when you build solution, what you're actually doing is you are creating an executable file inside of a folder. I can even show you right here. This is our folder. If we go into bin and debug, we now have these files. This happened after we build it, compiled all of our code. So now if you want to, you can double click and you can actually open this up. You could send an executable to someone. So that's what happens when we're building. We need to build to make sure everything is up to date and working. When you run your code, it will automatically build for you. So here is the part where we're going to add our unit test. So here it says on the file menu, add new project. So on our file, we're going to come over and we're going to do add, not new. We're doing add because we're actually adding it to this solution here. It's going to be concurrent alongside of our bank 2. So we're adding new project. And now it wants us to use MS test unit test project. So we're going to do, I'm just going to type in test first. And here we go, MS test project. Now, if you take a look, I actually have a lot more options for testing than just this MS test. We have NUnit, we have unit test project for .NET Framework. We have this XUnit. That's how important unit testing is and all this testing is. There are all these different frameworks, and this isn't a C# independent thing. There are all these, any language has a unit testing framework so that you can look into. Java uses JUnit, and it works almost exactly the same. So if you're interested in learning unit testing in a certain language, look into frameworks. I'll make sure to put links online for you to help kind of track down that information for you. So I'm going to take this MS test project, and let's see now. It wants us to give it a name. We're going to name bank tests. Next, let's see if it yells at us because I had another bank test. Here we go. So you may have noticed that it was all kind of red for a second. That's because it needs to import the dependencies for using unit test. Because this is .NET 6, you'll find a usings CS. This is our global using. This allows us, if we're using the same usings over and over again, we can put it inside of this global using and it will share it amongst everything in the project, so you don't have to put it on each individual file. So we have our unit test, and let's take a quick look here, see what's going on. You'll notice this looks like your standard class, but it also has what's known as data annotations. These are in these little square brackets, and we have these keywords here that actually indicate to our compiler, to our program, hey, this class is meant for something specific, or we're supposed to be interacting with it in a certain way. Because we're doing unit testing, we have to flag it, hey, this is actually a class built specifically for testing. And you notice that we also have the same thing for a method. Outside of that, these tend to all be built just like a class. I'm even going to do test method 1 here, class, namespace. So we'll go ahead and keep moving on. Added. Now we need to add our dependency. Even though these two are in the same solution, they don't recognize one another. So what I'm going to do is I would need to make sure that this bank test can reference bank 2. So I want to be able to look at this bank account inside of my bank test. So I'm going to come over here to bank test. I'm going to click on dependencies and right click. And here I'm going to hit add project reference. And you should notice the other project show up. Here we see bank 2. So I'm going to click on that and hit OK. And so now here we should have our, we should be connected. Here we go, projects. Our bank 2 is connected. So we don't want to connect. We don't need to add the dependencies one to bank 2. In fact, we don't want to do that because then it's circular dependency. That's not good. You want to avoid that. So we're set up. I'm going to come back on over in the reference manager, expand projects, solutions, and select bank. We've already done that. Now we're going to create our test class. So here we're going to rename this file they already gave us, this unit test 1. We're going to call it bank account test. I'm just straight out grabbing the name, copy and paste. Rename, paste. If you get this pop-up, it says we're renaming. Would it like to basically refactor everything where unit test 1, our old name, appeared? Always hit yes, unless you know what you're doing, because if I rename this and this didn't match up, our code would start yelling at us. It's expecting these to be the same. Refactoring helps take care of that headache. And so now we've renamed, is now called bank account tests. We are good to go. Now inside of here, as you see, we're looking good. This is exactly what we have. Now we need to add our using statement. We've done this before in other projects like using system. Here we need to make sure we're doing using, and we're going to do bank 2. It needs to know we're referencing this namespace right here, the bank 2, inside of here, because we're about to do instances of this bank account object. Test class requirements, as you see, the minimum are a test class and a test method. This is a very simple way to get started. There are a ton of data annotations you can use. There's a lot that goes into this. I will be honest, this is easier than your standard computer science programming. You're not necessarily creating new projects so much as you're writing code to test. So you're using all these frameworks, but that doesn't mean that you don't have a ton of options to work with. It is still a skill you have to learn, but unit testing is one of the best entry-level jobs you can get. So here we're going to create our first test method. Inside of here, we are going to, we are actually going to write 3 different methods here to check for different things. The first is to see when we throw in an amount, if the amount is greater than the balance. So let's say we have $100 in our account. Are we, let me see, we'll do. My apologies. There we go. We have $100 in our account and we try to overdraw it. We are going to throw an error in our code. We want to make sure the proper error is thrown. Same thing here. If we try to debit an amount that's like negative, so if I tried to do -20, it would also throw an error. But I don't want to just check for errors. I also want to check to make sure that it is working properly. So we are going to check to see that if I were to debit a certain amount, that I get the result I want. That was actually the first method we saw when we started this video. So we're going to come down here. We're going to, they say, get rid of this test method. So we're going to do this because we're going to be building our own new one. So here they give us the code, but I'm actually going to walk through and type it out here first so we can see what's happening. We're creating a method, public void, debit with valid amount updates balance. Notice it's a very distinct name. It tells us exactly what's going on. So we have debit with valid amount updates balance. Take a look here. They gave us 3 comments: arrange, act, and assert. These are the 3 key things you're looking to do whenever you're building your code. Arrange, act, assert. Arrange is basically getting all your fields into place and getting them organized to work with. So here they're literally typing out everything. We're not passing anything hard-coded into our code. So we have our beginning balance, which will be $11.99. Our debit amount, so how much we're removing, that's going to be $4.55. And then our double expected, this is the expected value, which we saw earlier, $7.44. And now I'm going to create a new instance of our bank account object. So account equals new bank account. Walton. And so here it takes 2 things. It takes a name for the account, which is not going to matter on our testing, but it takes the beginning balance. So we're just going to pass in this amount here. So now our next step is to act. This is the action. What are we doing? We are calling our method to debit the account, and we're debiting the amount right here. So beginning balance here, debiting amount here. This is our act, our action we are taking. And now assert is directly related to the testing. When you assert, you are basically checking to see the result. And this is the thing that's going to give us our pass or fail. So here we have our actual. So we're grabbing the account balance now. This should be the balance after we've debited the amount. And we are going to use a method associated with our unit testing framework. It says assert R equal. These are very literal. Like they give us a ton of options, but they all mean exactly what they do. Are they the same? Are they not the same? Does this equal? Does it fail? Is it inconclusive? You'll want to look through and find the one that suits your needs. But again, it's very easy to find something you're looking for. So we're looking for R equal. And this will take 4 parameters here. The first is the expected. This is the amount that we expect to come out of our balance. This is the actual. So what we expect to see, what we actually have. Because we're dealing with decimals and money, it may not be exact. We want to have a little wiggle room. And so that's what this is here. We're saying, all right, within it can be off by 0.001 and we'll still be fine with the result. So 0.001 is it? Yeah. And then account not debited correctly. This is just a message that'll pop up. So we've recreated this method. You can copy and paste if you want, but I just wanted to work through it. But notice I have not yet put test method. This is important. We need to make sure that data annotation is here. Once this is all set up, we are going to build again. If we build, it doesn't run. So that's a nice thing about building. We don't have to worry about it popping up. Our build succeeded. And now what I'm going to do here, we don't see our test explorer. I'm going to come up to view, come down, and we will find our test explorer. There we go. I just like to dock it on the side here. So as we notice, we now see that our test has not even been run yet. Debit. Let's see what happens here. Does it even recognize it? Doesn't even recognize it. You need to have that data annotation for it to even recognize the test method. So we're going to put it back, finds it. We're going to come up here to test. We're going to run all tests. And it works, but we got an error. All equal failed, expected a difference of no greater than 0.001, actual value, account not debited correctly. That's nice. It's really good to know. Why didn't this work? Well, that's because they gave us code that was broken. We come over to our bank account right now and take a look at the method debit. We'll notice that debit is actually adding the amount. So the amount that we're getting is not going to equal 744. It's going to equal something like 9 or like 13 something. So we're going to switch this around. Let's fix our code. So now this should be working properly. I'm going to come over here, build solution. Saving is not the same as building. So don't think just because you saved it, built your project, you need to make sure to build it and or run it. So now we're going to run our test again. Perfect. We fixed our code. It's now working. So as I keep going, unless I tweak something in debit, this should continue to flag us green. That's great. So now we are going to keep expanding. We are using our unit test to improve our code, make sure everything's working efficiently. We're going to go ahead and create and run some new test methods. So this one only tested to see whether or not debit was working. But as you see here, we actually have some validations. Meaning if we were to pass an amount that's greater than the balance, it's going to throw an error. If we have an amount that's less than 0, it's going to throw an error. And we want to check to make sure these are working too. So we're going to come back over to our account test and take a look here. You'll actually see these little icons telling you your individual methods, whether or not they passed or failed. They make it really easy to identify this stuff, because when you're making like 75, 80 bucks an hour, if not a lot more, every second counts. So they want to make this as streamlined as possible. In fact, if we go over to bank amount, you can see on top of everything that has a test associated with it, if it's passing or failing. So this stuff is great. I love how efficient this is. So we're going to come back over and create a new test. I'm just going to straight out grab this one. It's another test method. This time, debit when amount is less than 0. So if we were to pass in a -10, should throw an argument out of range exception. So same thing here. We've only built, you're always building an instance inside of the method. You're never, you don't tend to want to build, you can build a more global instance, but I wouldn't suggest it, because you always want to make sure you're dealing with like clean data. So here we see our beginning balance, our debit balance, which they give us is -100. We know that would throw a flag. And then we're building our account, our instance like we did beforehand. And this time they're using slightly different syntax, but they're doing the same thing. Here we're doing our assert. We're looking for that it throws an exception. And so this looks a little different here. If anyone has not yet dealt or understands what the carets are, when we do well, first let me say this. We've seen this before. If you worked with list and you've used carets, it's just a way of saying what type you're about to interact with, because it can be used to create a generic type, because we can have many different exceptions, and we'll take a look at the different exceptions that we can be looking for. Throws exceptions, see that has the carets. And then let's see what options we have. I just did control space to bring up IntelliSense, and array type mismatch exception, assertive, assert including inconclusive exception, assert failed exception. These are all exceptions that we can be checking for. Here we are checking for our argument out of range exception. So that's what I'm putting in between the carets. And then we are calling this method using like a lambda. We're not going to get into lambdas here. I would say just copy and paste this code for now, but we're essentially calling this method and we are returning this debit amount. We are debiting the account and it's waiting for an error to come back. And so it's checking to see that we do get this argument out of range exception, which if we check back over on our bank account, that is the type of error being thrown. And as you see, it's already shown up because we have it listed as a test method. So we're going to go ahead, build, run, works. because we know if we passed in negative 100, it throws this exception. That's perfect. And now here it's asking us to create a new one that's also going to check to see if we are overdrawing a balance. That's really simple because it's basically the same thing as this debit when the amount is less than 0. We're going to copy and paste debit when balance is overdrawn. And so if our beginning balance was $11.99 and I tried to debit 100, that's going to be overdrawn. This should still work for us. So see here, my debit balance appears. Let's go ahead, build, run. So far, so good. It looks like everything's working. We're checking all of our validations. I'm very happy with where we are right now. And we're going to keep going. Because while this is good, this is working, we have just passed really generic errors into our debit, right? Like if I were to get an error, I would not know the difference between if it was if the amount was a negative amount being passed in or if it was being overdrawn. We don't want to have this really general name here. So we're going to make this a little bit more specific. So here they're saying we're going to refactor the code under test. So the first thing I want to do is I'm actually going to come over to my bank account class. So not my test, but my bank account. And now I'm going to come over and they've given us these 2 fields to add, these constant strings. We're going to add them up here at the top. And again, for anyone who doesn't know, a constant is a field where after while your code is running, you cannot change the value during runtime. So here I could not do something where I changed this string for debit amount exceeds balance message. I don't plan to change it, so we leave it as constant. It doesn't really affect the efficiency of your code in any large way. It's just more for us, so we know kind of what it's doing and that it's important. I don't expect to change it. So here we're going to modify the 2 conditional statements inside of our debit method, right? So here we have our 2 generic throw new arguments. But as you see, they give us something a little bit more specific here. Let's take this first one and we'll pass it in and then take a look. I'm going to replace the amount is greater than balance, still throwing an argument out of range exception. But here, what we're doing is this takes a parameter name. This will take the amount. So we're actually taking the amount passed in. So that means we're probably going to display some key information. And then here, the last one is the actual message that will be displayed when your error is displayed, when you can access it using a try catch. We'll be taking a look at that. This debit amount exceeds balance message is this exact same message right here. And you'll see why we made this public and easy to access. So we're going to do the same thing for our second one. Our messages are now more specific. It is no longer just an amount messed up. They're displaying the amount, and then they're passing in their own specialized messages. This is great. So now we're going to refactor our test method. So we're going to come back over to our tests. And now the first one we're going to do is this when the amount is more than the balance. So all of this stays the same. But now for our act, instead of having this one lambda here that does everything, we're going to now, I'm just going to copy, or I'm going to comment it out. If you don't know how to do shortcuts on commenting, I highlighted everything and did Control-KC, but you can also use these little hotkeys up here to comment and uncomment your code however you see fit. You want to get used to using hotkeys, it speeds you up greatly. So here I'm going to do act, and then let's go ahead and just copy and paste and work through it. So we're going to do our try catch. And for anyone who has experienced try catch, a try catch is a code block that is specifically made to catch the errors or exceptions being thrown out of your code and to respond to them properly. If we didn't have a try catch and we threw an error, your program would just crash. A try catch is useful for helping prevent that and responding to the error. So anything that we're going to run that we fear might have an error, we're going to put inside this try block, as we see right here. But then down here, we have our catch. And if you notice, we're actually listening for one specific exception, this argument out of range exception. And this E is the variable name that we're going to use to access the exception being thrown. And so if we take a look down here, no longer is it just assert, it is string assert. We are going to be calling contains because we are checking to see if the string being returned is a very specific message. We want to make sure that the error being thrown is the message we expect. So here we are doing E message, E dot message. Again, E is referring to this local variable. Then we have all these different things, these different fields we can access. We're doing the message. So it's returning a string. And then this is the message we expect to see. So here, if we come back over, we're accessing our bank account and we're accessing the message debit account exceeds balance message. That's this. Because we want them to be equal. We expect them to be equal. I could technically hand key this and type this myself in our bank account test. But anytime you have a piece of information you expect to be consistent and you're having to hand type it or change it manually in multiple places, that just opens the door for all these errors to happen, and you want to avoid that. So here we're consistently using the same message being passed. So we come back over to our test. And now
you might have to explain this one more time.
Oh,
Yeah, like how is the exception being passed in, and how is the message being
accessed.
yeah.
Of course, and thank you for asking. So here, first, let's go ahead and start off. I'll just show you what happens when we do run it. We are going to build, and we are going to test. This changed, that's fine. But let's see now. String debit amount is less than 0. Does not contain the string debit amount is less than 0. So what should be happening, and I'm glad we are here because I'm just going to straight out take this right now and make sure that I'm doing this right. Build. There we go. I probably just mistyped something someplace. So as to answer your question, David, which was a great question. So we have a couple different things happening here. The first is inside of our debit method that we've built, we have some validations, specifically checking to see if amounts are greater than the balance or if they are less than negative, less than 0. So if we're passing in a negative amount or we're trying to overdraft our account. So here we are throwing our exceptions. And so this is, when you've done something and you get an index out of range exception or anything like that, what's happening is there's a bit of code someplace that is doing what's throwing. It is throwing an exception. And here inside of our code, we're saying, hey, we are throwing this exception. And we could have just left it at this essentially. And it would throw our argument out of range. But that's a really generic exception because it does kind of tell us what's happening, but it doesn't tell us where, doesn't tell us why. So we've gone ahead and used an overloaded constructor. In fact, if you take a look here, you can see that it will even say there are 4 different overloads for this. So you can pass in different amounts of information. But here, this is passing in a parameter name. This is passing in the amount. So that way we know how much money is being passed in or what a value is being passed in. So we know specifically what to look for. And then this third parameter is a message. And that message is just a field in this exception that will be passed through to our code someplace else when it gets called. So the message that appears elsewhere in our code is this debit amount exceeds a balance message, also known as this. I could literally do this. This is the message being passed.
Yep.
Yeah. But we're creating a field for this. So that way, because we're going to be comparing it someplace else, if I had done this, as you already saw when I was typing the code, something messed up. If I had done this, and then I decided over here, I was like, well, I'm expecting that message. I'm going to do this, but then I mistype it. That error isn't because our code isn't working. That error is because of a human error. So I don't want to do that. So That's why I'm accessing this field right here. I've made it public. It's a constant string. And I'm just accessing it inside of our code by doing bank account, the name of our account, dot, and it shows us all of our fields that are available. Our debit amount exceeds balance. And so it's returning the same string. It's comparing the same string. And
Gotcha.
yeah. And then as for how we're even accessing that message, so when we do our try and we try calling our amount and we know that we're trying to access it, the debit amount is 20. And so this is going to throw our error. It's going to hit our validation. It's come down here and it's going to throw this amount. Oof.
So throw is slightly like it's different than a return. So throwing an error means like since this method here, it has a void for a return. So like if you throw the error that makes it catchable in the try catch.
That's it. That's it exactly.
Okay.
Throw is it's an interesting term directly related to errors. And when you throw it, you actually have all these different places. You've seen it when your code crashes and you get that huge block of code that's the stack trace. When you throw an error, it's not just saying, hey, here's an error. You can actually throw it up to different levels, different try catches. You can have it respond to different things. Throw is directly related to only throwing errors. Does not relate to the return type. In fact, when you throw an error, it stops your code from running right there. It won't go any further than this. So in that way, it actually kind of works like a break or a return. And that's kind of where you want to dive in. It's a bit beyond the scope of this lesson right here, but you can create your own custom errors and exceptions and have it pass in different information, because not everything is going to need an argument out of range exception. So you can create your own exceptions, no matter what you're going to be throwing new ones.
Do you need so in order to catch these exceptions, do they need to be in a try catch?
Yes,
Okay.
that's a great question, because a try catch is essentially an if statement, but specifically for catching exceptions. Because if we tried this, let's see what happens here.
Yeah, then it'll just yeah, actually I don't know what will happen.
Let's see now. Let's come over here and run our code. Like actually run. So here, debit, credit. We're going to debit a large amount. Let's run it. We have an exception. It threw our exception. This is what you would usually see if we're debugging. Otherwise, your program would just crash itself. But if we were to come back over to our bank account, come down here, try, catch, and then I'm just going to do a generic exception. This is like the same way an object is everything is an object. All exceptions inherit from exception. So I'm going to just catch all exceptions. And then I'm going to, because we're working with console, let's go ahead. I'm going to access this object, this name that I gave right here, dot message. And we go ahead and run it this time. Instead of crashing, we actually see our error message appear. So I'm responding to that error with a try catch. And so whenever that try catches are specifically made for this. Keep in mind though, that if you're writing your code, what you tend to want to do is use exceptions for those instances for things that you may not be prepared for. And that sounds weird, but if you know you're going to have something like on your bank account, I may not necessarily have it so that it throws an exception like this. I would actually have it written so that way it responds. It doesn't do a try catch. It doesn't crash or anything like that. It's just like it'll prompt the user, please enter in a different value. So that's something to keep in mind. You use your if statements to check for validations you know about. You use your exceptions to watch for things that you may not be prepared for. Does that make sense?
Yep.
Cool. Well, great question. So we're gonna come back over here. At this point, let's see. Let's try running this again. We're going to build, going to test. There we go. This is working properly. Now we're just going to refactor this last one here. I'm actually going to take this same code. We know this is for overdrawn. So overdrawn. So debit amount. Actually, let's see here. This is for this one. This was for amount is more than balance. Did they give us? Did they give us the same one for each? They'd probably expect us to rewrite it, and I am too lazy for that nonsense. So here we go. I'm actually not too lazy. We're going to go ahead and just take our try catch. We're going to replace it here. So it's still debiting, but this time we're listening for the negative. Then let's see now. This is actually going to be amount is negative. And now this would not work because this is for a different message. We are going to do the less than 0 message. And we are now going to build. And we are going to run. Test. Run all tests. Looking good. So all our tests are working. This is perfect. And we've hit the end of our tutorial. This is what you want to look for. You're building your test out. We were testing for one very specific thing. We were testing our debit method. We wanted to check for the 3 key things that it was responding to. Did it actually pass a proper, did it work properly? Were we properly debiting the account? And did we throw the proper errors? Now, let's say I wanted to keep going here and I wanted to move beyond just this debit one. Let's take a look at our bank account. There is, let's see now. We also have a credit one. That should pass. There we go. We also have a credit one. So let's just quickly make sure that, let's just quickly write our own custom test to make sure credit is working. I'm going to come over here to bank account test. Public void credit. So I'm saying which method I'm working with. What they call it, with valid amount. With valid amount, and then updates balance. Updates balance. So again, we are going to do our arrange, act, assert, arrange it. What we're saying is we're going to do our double beginning balance. We're just going to make it simple. We're going to say 10 double credit amount equals 5, and then bank account, or first double result, we expect 15. And now we're going to create an instance. When you're doing these unit tests, you actually always do them for instances of objects. And if you talk with the other professor, Josh Emery, you'll hear why abstract classes are used so much. Because if you have an abstract class, you don't need to make a unit test for it, and that's very convenient because you would have to write a lot of unit tests otherwise. So we're going to do account equals new bank account. We'll just give my name, no Mr. here. Beginning balance. All right, we have arranged our information. Now we're going to come over here and account. We are going to credit our credit amount of $5. And in our assert, this is where we're actually testing for things. We're going to be using this assert are equal. In fact, we'll just copy this right here. Account balance. So it should have updated to 15. The expected is going to be our result. We should actually, expected is a better name. So expected actual account. Let's see now. This only appears if something errors out. So now it does not show up. We need to do our data annotation test method. Give it a second here. Credit with valid account amount. So now I'm going to build. I'm going to test. And there we go. We wrote our own custom unit test for credit. I can keep going here, build one. As we see, there's another validation one here. This is just a process. If you'll notice, it's very much the same thing over and over again. There's nothing wrong with that. I do like to call out a couple of things when you start looking into unit testing. It is a very, it is not spoken about as much, but it is also a very lucrative part of computer programming. Almost every company, if not every company, has testers because all their code needs to be tested in some way, shape, or form. There's unit testing, SDET testing, automation testing. There's lots of different testings, but they all basically resolve to you write some code that will check to see if something's working properly. I'll make sure to post links about that in the future. It's actually quite enjoyable if you don't mind the fact that it's not as creative. And that's a thing. Like if you're a software engineer, you're constantly solving problems. With testing, you're not really solving problems. You're always just trying to break the tester's code. And that's a ton of fun in its own right. So if that seems fulfilling to you, please go ahead and look into testing. It's a great career. And I mean it as a career. You're still making 70, 80,000 plus getting started. But one big caveat that I like to call out, and that's from experience with one of my closest friends, Moisen Nizamudin. He was a unit tester. He started testing in his first year after being recruited by Microsoft. So he was already in unit testing. He did unit testing, or he did testing for like the last 10 years of his life. They're so in demand that it's actually harder to get out of being a tester. He had to downplay his testing abilities because every time he went for a career as a developer, they were always like, hey, we noticed you're a tester. Would you like to do this instead? So just keep that in mind. If your passion is programming itself, that might be a hurdle you have to look for in the future. But other than that, this is a great job opportunity and worth checking out. So I will have additional materials and links so you can start diving into it. I got started unit testing just basically going on to lynda.com, which is now linkedinlearning.com, and just doing the tutorials online. I've done JUnit and I've done, C#, and every industry has it. You can do it for game development. You can do it for web stuff. It's great. So yeah, this is our look into unit testing, getting started and everything. If you have any questions, feel free to reach out. Does anyone have any questions here in our class today?
Yeah, you're going to be continuing this, right?
You know what? I would like to. I'm going to actually discuss with Josh if we would want to move forward and the best way to move forward. He's done a lot of unit testing for his master's class. And honestly, what I would really like to do, and I will be happy to reach out, I'm going to see if Moise can drop in and tell us about his experience with testing. How's that sound?
Yeah, that sounds good.
Cool. So yes, I will make sure to keep everyone updated as we continue on with unit testing and talk to you a bit more about it and how to get into the industry as we find out information. Also, there are other types of testing such as automation testing, which is quite a bit of fun. So we'll touch on all that in the future. So again, if you have any questions, feel free to reach out. I'll go ahead and post this video online. Thank you for being here, and you all have a great day.